All right. Sorry, just getting the record button. Okay, so DVT is an insurance company, as far as I'm aware. They basically have different providers, different members and subscribers. So, I mean, a lot of the data and things we see in the application are things that you might be interacting with, like for your insurance portals and whatnot as well. So, like what you might have for Aetna or any of these providers, you know, you'll have subscribers, you'll have dependents. You'll have different plans for each of these and all of that. So that's what they provide. And as far as the actual back end of this goes, they have a database table that has all of the coordinates of a lot of their members, not every single one. We'll get into that a little later in the presentation. But basically, that's where the data lives. And so, like I was saying, basically they wanted to be able to select different addresses, different points on a map, and see how many members were within a certain radius or within an intersection of these radius. And so, like I was saying, when I got started, I got the requirement from one person that, oh, we just need to be able to enter in 2 addresses and then, you know, boom, show us the members. And it's like, oh, that sounds real simple. And then I was talking to another guy and he was like, well, actually, sometimes we get 3 or 4 addresses, you know, we need to be able to see the intersections of all these and the intersections of the intersections. And so with these varying requirements and then no description in the ticket, usually where I lean towards is flexibility. So I try to come up with something that would fulfill all of these requirements, even if they differ. So that's a little background. So first, when we dive in order to build an interactive map, we need a couple pieces. One, of course, is the map provider. So this is what's rendering and displaying the actual map tiles that you see. So if you go to like Google Maps and you see that map and you're playing around with it, there's something rendering it and there's something, you know, as you scroll around, it's finding the tiles. That's your map provider. You also need a tile source. So this is, of course, what you're actually seeing on the map. And there's a number of different pieces to those as well. You also need a geocoder of some sort. So when they enter in an address, you'll need to be able to get the latitude and longitude of that address. And then it's nice to have the reverse capability to also go ahead and say, hey, for this coordinate, you know, what's the address there? So for that, you'll need a geocoder. And then to actually determine whether coordinates are within some spatial geometry, we'll need a couple system classes to use in the backend. These include system.data, entity, and spatial, and then device location as well. And then finally, you'll also need some sort of algorithm to actually go through and search through all these member coordinates. So if we go ahead and move on, we'll see. So for a map provider, there's a number of considerations you want to make, right? So like first, you want to understand your requirements, right? And so, I mean, if you have the requirement to be very mobile compatible, then you're going to need to lean towards a map provider that, you know, of course, fulfills that side of the requirement. Another thing you're going to want to consider is the licensing / pricing model. So, I mean, a lot of these, from what I saw, it's pay per request. Some of them are subscription, and of course, some of them are free. The other things, you're also going to want to look at the features and functionality out of the box. Some of these map providers and tile sources are really lightweight, and you might have to do a lot of fancy footwork to wire in your functionality or your needs. Whereas some of these come right out of the box with things that you need. So I tend to try to lean towards those, but of course it's a balancing act like everything. You'll also want to know, of course, the compatibility of the map provider with your tile sources and geocoders. So some map providers are really picky about what tile sources you use and what kind of geocoders you wire into it. And then some are a lot more open, they're a lot more friendly and have a lot more open source options. And then finally, you also want to consider the dependencies. So some of these map providers, they come with a dependency on jQuery, or they like I was mentioning, they come with a dependency on a certain tile provider. And so that's going to limit your choices and what you can do depending on what map provider you've chosen. So if we go through a couple map provider options, as you saw in the title of the presentation, Leaflet is, of course, a map provider. It's open source. It's a simple JS library. It has no dependencies. It's very small, very easy to use, feature rich, works with configurable tile sources. So in DVT, I actually have it so that there's an enumeration that represents tile sources so that they can swap around tile sources if they choose to go pay for another one. Because as you'll see, some tile sources look a little prettier than others. And of course, the free one doesn't look as pretty. But other than that, it gives you that flexibility to just toss in whatever source you need. And then furthermore, it has a lot of plugins. It has a lot of extensibility to it. There's a number of open source packages and JS libraries for it. And a lot of people use it. So a lot of people talk about it, and it's on a lot of forums. So this one seemed like a good option. Another one that we looked at was JHere. It works with here map tiles, and it also depends on jQuery. And then on top of that, it's not the most feature rich. Doesn't have a lot of things you would expect kind of out of the box a map provider to have, but it is free. So the map provider itself is free. Here tiles, as far as I could tell, they're not so free. So we kind of passed on that one. But another one is Gmaps. This one I thought was really promising. Again, very simple, very lightweight, and free. But again, as you might expect, not very feature rich. No dependencies, and but also, you know, not the very best documentation, not the most examples, tutorials, all that. But as I pointed out, it is free, so yeah, that's an upshot. And then there's Mapbox GLJS. And so this is Mapbox's map provider. This one is licensed, and you have to pay for it. It's per map load. So, you know, anytime someone comes up, loads up the map, that's a request that counts towards your map loads, and you have a limited amount of map loads on your license. But what they do give you is they give you as many tile loads as you want after that. So that's kind of nice. It is extremely feature rich, very well documented, and very easy to use as well. But of course, that comes with paying for a license and everything. So, and then of course, there's a number of other utilities that we didn't really dig too deep into, because again, you could skin this cat a number of ways. So I included a list here in case anyone's curious to kind of peruse through some more of these. We won't dig into any more of those though. So then the other thing, as I had mentioned, is you're going to need map tiles. So you're going to need actually, of course, what's displayed on the map. And so I mean, what are map tiles, right? And so Wikipedia's definition, there's packets of geographic data packaged into predefined, roughly square-shaped tiles for transfer over the web. And basically what you see is when you're on these maps, you've probably seen it before on Google Maps, as you kind of scroll around, you'll notice some little squares are gray and then some squares load. Well, those are each tiles, right? And how they render them and how you load them and all that, that varies whether you're using vector or raster tiles. But again, they're kind of changed as you zoom around the map and move around the map. Generally, especially if you're using raster static tiles, it's a separate request per tile. If you're using vector tiles, it's not necessarily that way. It depends on what area or what vector you originally loaded down and whether it can actually map those tiles out from that or not, and whether it needs to request a new one. And so as you can see, there's an image kind of, you know, showing at a simple level what tiles really represent. So I mean, if you had some simple raster tiles and I'm up at a high level, I'm going to see that top one at the top pyramid. But as I scroll down, you can see it's broken into 4. And then you scroll in further, it's broken, you know, into the 16. And so that's kind of how these tiles work, right? As you zoom into different areas, different coordinates, it's going to choose different tiles to piece that map together. So, of course, similar to the map provider, there's a number of considerations you're going to want to, you know, take into factor when you're picking a tile source. So again, as a lot of these are going to have, it's the first pricing model, right? So, I mean, generally a lot of these are paid per request. Mapbox was the one that was kind of different, you know, where you could pay a license, and if you got the map GL, then they just give you requests, you know, as many requests as you want because you're already paying them for something else. So that kind of varied, but most of them are per request, and you get, you know, a couple thousand requests every month, and then if you pay more, you can get more. There's different tile options, of course. So, I mean, again, I like to compare this to Google Maps because everyone's familiar with that, is how you can go to a satellite view, you can go to a road view, you you have different views. Well, each of these are, again, just different tiles mapped onto these geographic areas. And so there's a number of different tile options that you can get from some of these sources. Some sources have a ton of options, and then some sources only have one or two. So I mean, if your requirements are, I got to show some topography, or I got to show a satellite image of something, then you're going to have to lean towards another tile source that, you know, fulfills that. And then finally, you also want to know whether your tile source will integrate well with your map provider or not. Again, a lot of map providers, they're going to allow you to customize your tile source, but some of them, like Mapbox and whatnot, or J here, they're going to be very specific to one tile source. And again, will control what tile source you end up picking. So if we go through some of the tile sources real quick, we'll see, you know, we got, again, Mapbox has their own tile source, so you can just pay them for their tiles, or you can also, you know, buy their interactive map provider, and then they'll just give you tiles with it. It's not free though, of course, and there's a trial option available, but I don't usually like to lean on those too hard. And again, their tile source is per request. There's OpenStreetMap. That's actually the one we ended up going with for DVT. It's free. It is dependent on their API, which at times can be slow and at times can be fast. And I mean, again, it's, since we're not paying for it, there's no real, you know, SLA or anything. So that's one of the things about that tile source you have to consider. So if you needed a really robust map, you might want to actually force them to say, you know, recommend we pay for, you know, Mapbox or Thunder Forest or some other map provider. And then on top of that, of course, OpenStreetMaps only provides a limited number of tile sets. As far as I saw, it's just neighborhood and satellite, if I'm recalling correctly. But again, and that makes sense given they're free. Thunder Forest was another that I kind of glanced at and looked around, and again, not free. They have a trial option, but the upshot to Thunder Forest is they have a variety of tile sets, like just a ton of tile sets. So if I go back to this slide, you'll see all of these tile sets that I pulled right here are just examples from Thunder Forest. And they have many, many more than that. And then on top of that, ultimately, you can make your own tiles, but again, you know, it's going to be a very manual solution and probably not the easiest route to go. And then there's other tile providers as well that I didn't delve too deep into. I'll pause there real quick for any questions or anything. Oh, okay, perfect. So the third piece we're going to need here is a geocoder. So what is geocoding, right? It's the process of taking, you know, an address and turning it into coordinates, or you could say vice versa. I'm going to take in some coordinates and spit you back out an address. There is forward and reverse, and this is just for which way I'm looking up, you know, whether I'm using coordinates or an address. Geocoders will generally have just an API endpoint that you're passing this stuff to, and then they're going to spit you back, you know, some list of results. Some considerations when picking a geocoder are mainly, if you have to do any of this in the back end, which we did in DVT, you're going to want an SDK or a package, because you're not, you could ultimately spin up your own HTTP client wrapper that you're going to say, hey, this is my geocoding HTTP client, you know, I'm going to use that to communicate with my geocoding API. But again, you're having to do a lot of the legwork on just communicating to that API, let alone actually getting the data, you know, and making sure it's right and all that. So generally, a lot of these, if you look around, they'll have, if they're pretty good, they'll have a .NET, you know, SDK or package that you can just go ahead and pull down. Either it's maintained by them or some other open source project. You're going to, of course, want your geocoder to ideally integrate with your map provider. That way, for fast geocoding or some simple like click geocoding, you can have that a little faster. You can have the client side communicate directly out to that API. And again, if there's an easy integration, you don't have to handle all those API messages and calls to that API. It'll handle that within that solution, that package again. So this is another thing you might want to consider when picking your geocoder. Of course, you always want to consider, like all the others, is pricing. Most of the geocoders are very standard in the sense that they are charging you per request, or they give you a number of limited requests you can make in a given time period. And of course, you pay more, you get more requests, you pay less, you get less requests. And then finally, of course, documentation and ease of use. So you don't want to pick a geocoder that, you know, isn't used widely or doesn't have very good documentation, or is very complicated and convoluted to use. So for geocoders, we ended up looking mainly at OpenCage. So OpenCage, it comes with a nice .NET standard NuGet package that is well maintained. It also has a nice Leaflet plugin for forward geocoding. So that was, again, really handy, so that then when the user clicks on the map, I can immediately geocode that to an address. And it doesn't have to go through our backend, then to their API, and then come back out. It just goes boom to their API and comes back. There are plenty of open source plugins for OpenCage. OpenCage, in fact, is one of the ones that I saw where they're very proud of how many things that they work with, integrate with, and have packages around. They had something pretty much for anything you could imagine. Let's see if I have the list still. I think it might be in a later slide, but there's a comprehensive list. So I mean, React, all these things that you might expect, it's got something with. So I was very happy to see that when I was looking at OpenCage. And then OpenCage does offer a free trial option, 2,500 requests a day, and it's pretty straightforward. But as I pointed out, and as they'll point out on their site, is of course, if you're relying on this for real production use, then you're going to want to pay for an account, because like they point out, these free trial accounts, whatnot, they'll sometimes kill the keys. And then on top of that, you might reach this 2,500 request max. And then on top of that, you're limited to 1 request per second when you're not paying. And so again, if you're going to use this for some serious production usage, you're going to want to pay. And then finally, of course, OpenCage, again, with all of their SDKs and whatnot, they also had a number of tutorials on how to use even all of these open source SDKs and everything. So OpenCage was very nice to see. Mapbox is, of course, another geocoder. So it's like you could go all in one with Mapbox, you know, geocoding, your map provider, and your tile sources. But of course, when I took a glance at their SDK that they have, it's not very well maintained. The last update to it was 3 years ago, and the build on it is failing apparently too. So that kind of steered me away from this, at least from a geocoding perspective. Of course, this integrates with all the other Mapbox stuff. So again, if you drink the Mapbox Kool-Aid, then this is gonna just flow right in like butter. But this doesn't have many open source plugins, as you might expect, because they're trying to push people to use their stuff. This reminded me of, this was like Telerik or Kendo, you know, for map providers and whatnot, where they got it all in one, but you got to make sure you use it their way. And of course, again, this is pay per request. So we ended up, of course, choosing Leaflet and OpenCage. And then, like I had mentioned, for the tile source, we went ahead and did OpenStreetMaps just to be free. But like I pointed out, we have the option for Mapbox tile sources if we want to swap those out, or if mainly it's if DVT decides they want to pay for nicer tiles. So finally, some of the things we'll need in the backend are some .NET system dependencies. So since we're actually going to have to calculate, you know, hey, is this member coordinate inside of this, you know, geographic area? Ideally, we don't code in, you know, some crazy complex SQL trigonometry calls, or just, that's apparently what they had before, was they had some stored procedures that were basically doing the things these system dependencies would do under the hood. And I took a glance, and it's some pretty nasty SQL code that they have in those stored procedures. And so basically this kind of abstracts that away, and you can make these high level calls from C# in your backend versus relying on anything in SQL and stored procedures and all that. So mainly there's two. You need system data, and that's for system.data.entity and for system.data.entity spatial. These packages actually require either SQL Server tools or a specific NuGet package, which has these two DLLs that you can see in that screenshot there. And so like when I was building this locally, everything was running fine locally and everything. It was all great, you know, and I got it into a pull request and, you know, we reviewed it. And we're like, awesome, this is great. And then boom, as soon as I go to push this out in the test run, because I have some tests around the locator, tests fail. And the tests fail because basically they can't find these system calls. It doesn't exist. And on the Bamboo build server they of course don't have SQL Server installed. And locally, I've got SQL Server, all these tools installed. So that was immediately the main difference. And looking into it, you find, oh, it's these DLLs that it needs. So there's a specific NuGet package, if I'm not mistaken, it's called SQL Server types or something like that, like Microsoft SQL Server types. And when you install it, it'll go ahead and actually make this folder, and it'll add in these DLLs in this little loader class. And then all you do is you call this loader class when the application starts up, and it loads in these DLLs. And then you can use these system calls, you know, on app service or function, Azure function, because that's where, when I was looking into this, I saw a lot of people talking about running into this was when they ran it somewhere that didn't have SQL installed. So that is all required for the usages of the DB geography classes and methods. And then also system.device.location is needed to be able to interact with the geocoordinate classes, and if I'm not mistaken, I think DB geometry might come from there. But so those are two main system dependencies you'll need in order to kind of do some calculations on these geographic areas and, you know, whether coordinates within one or not. So like I had mentioned, we went ahead and went with Leaflet and OpenCage for a number of reasons. One is because these two options already have a very nice forward geocoding plugin. So it's nice enough to the point where when you put it in, it literally gives you this little search bar over in the corner. You can key in addresses, it'll look them up, you click one and boom, it's gonna pop up a little pointer wherever that is on the map. And that was very easy to wire up. Mainly you include their package and then you initialize it, and that's pretty much it. It's the actual plugin is an actual or active open source repository. It was updated literally just 2 days ago when I checked it. So it's well maintained, and it's very small, very simple. It's just got its own JS and CSS file. You just, again, include those on the page and initialize it. That's it. The other thing is, I was pointing out, OpenCage works with many open source libraries and tools. So all of those listed there are basically ones that OpenCage had SDKs, had tutorials, had examples, and would integrate with. So that was very nice, very handy to see, given that, you know, I mean, your client might have a different tech stack somewhere versus another. So now that we've gone into kind of, here's how we're going to set up, you know, the map, and here's the tools and the tech stack, you know, we're going to use. Now we get to look at kind of, well, how are we going to actually do this? How are we going to, you know, even if I have a map and I'm able to wire up all these tools, well, how am I going to find that? And so again, the problem is pretty straightforward. It's find members using these latitudes, longitudes within an X mile radius, so the user can, you know, change that radius around an address or a point. And then also to calculate the number of members within, you know, the intersections of these buffers. So the simple approach that was first told to me by one of the team members was, well, just loop through all the member coordinates and test if each coordinate's within, you know, a specific buffer, radius, or intersection. That is there's a better approach to this, right? I mean, then when you think about it, you go, well, wait a minute, I could be looping through, you know, tens of hundreds of thousands of coordinates, you know, and do I really need to go through every single one, or is there a way I can whittle down this list a bit? So a better approach is to go ahead and just box off the area that the user is actually searching in, right? So what you can do is you basically find the northmost point, you know, the eastmost point, westmost point, southmost points that they have selected, and then you add the radius for that particular marker. So I mean, the marker's radius was 7, and you're looking, it's the northmost point, you're going to add 7 miles north of that point. That's the top box, top border basically. And so then you can calculate, well, what's the northmost, latitude, what's the southmost latitude, what's the westmost longitude, and what's the eastmost longitude. And then you have yourself a box, and then you can just query and pull up all the member coordinates within that box. And then that way, you're also only making one database trip for all these coordinates. And then you can operate them all in memory. So with that, we can whittle down to exactly the area that the user searched on, use that subset of results to further find if these points are within, however many buffers they've specified and however many intersections happen to crop up. So there is some complication to this though. So you can't just add, 7 miles to this point, right? You can't just do that because the Earth is, of course, not flat. And so given that, there is some trigonometry that's involved. Luckily, again, there are some comments on this. I found many discussions on how to do this, and you can actually do this without trigonometry, but you'll never get a precise number. You'll always have an estimate. And it has to do with basically that nautical miles factor in some of this, and they equate to like 1 arc second or something like that. And so again, it's like you could try to calculate it that way if you're really, really concerned about having no trigonometry. But if you're able to or willing to, you can have just a small amount in an extension method, and then that way you can add miles to this point. And then that way you can calculate, again, this northmost bounding box and the southmost bounding line and all of that, right? So again, for that, just made simple extension method. I'll show it when we get towards the end here when I go through the code real quick. But again, not too crazy, not too complicated. Admittedly, I found it somewhere else too. Of course, I did not go out and write this trigonometry and this extension method myself. So once we have all that, and we're looking through these member coordinates. First thing, of course, we're going to look through these buffers, right? Say, hey, did this member exist in this buffer, right? And so we're going to go through all the buffers, and we're going to do that. And then we have, okay, well, here's how many members are in the buffers. But then you need to find how many members are in each intersection. Well, the problem comes up is intersections of intersection. An intersection could have an intersection that could have an intersection that could have an intersection, and so on. And so you can see how this is leading somewhere. And so, of course, this is a great case for recursion. And so the base case here, of course, is no intersections. So if we're going through and we find no intersection, then we're just returning an empty list and we're done. And so again, I'll show this function here in a bit, but it basically is just looping through these areas, searching for intersections. If it finds intersections, it's going to call itself on that, finding any intersections of that intersection, and so on and so forth. And so you can see how that method lines exactly up with this use case in this scenario. So once we were able to go, okay, we've got our count for, here's how many members are within a buffer, here's how many members are within, all these intersections and intersections of intersections of intersections. We need to be able to show them, well, where we're going to put the point for, how many members are in this intersection. Like again, with the counts for the buffers, it's kind of easy. You got a marker, and I can just kind of put the number on that marker, and boom, I'm done. But with the intersections, where do I put that on the map? How do I display that? And so, ideally, you'd be able to put a marker right in the center of that intersection. But then you have to find the center of that intersection, right? And so, luckily, again for us, there's a nice built-in DB geometry call to get the centroid of a polygon, as it's called. And the centroid, again, as you might expect, is just the centermost point of a polygon that you could find. And there's again, another complicated algorithm on how to find that. But luckily, as you see from that little code snippet, there's a nice, simple centroid property, actually, of a DB geometry that we could just go ahead and pull up right away. So we use that to get our centroid, and then that way we can mark our intersection counts on the map, as you might be able to see here in the screenshot. So finally, now we got all our data. We got our algorithm down, and we're getting ready. We're going to return this data to the front end. We're give it all as JSON to the UI, right? And so for this return, I return what in my mind at least made sense and was object oriented accordingly to this kind of design is basically we've got a list of member results, a list of buffer results, and a list of intersection results. And so when you look on this map here, you can see all the little dots. Those are, of course, the member results. You can see the circles and the markers. Those are the buffer results. And then, of course, you see the intersection counts, and those are the intersection results. Each implements the same interface, I coordinate, basically meaning I have latitude and longitude. And then they contain any specific information to their count. So again, for the buffer results, you're going to have that members count. You're going to have, you know, maybe the marker ID for that, and then you're going to maybe have the address or something in like that, you know, for just extra metadata. And then for intersection, you're just going to have your member count and, you know, of course, your centroid latitude and longitude. For your member results, you're going to want to return maybe the ID of that member, so that then maybe you could provide a hyperlink, you know, if they click one of these member map markers. And so as we get more into the JS UI side of things, there's a couple little technicalities out here. So looking at the map, you could see, again, it's a simple layout of here's some buffers and intersections and all that. But we have to make sure when we display these markers or these intersections or anything like that, that we're only displaying one at a time. Because of course the map's going to let you stack these up, but you're not going to want to click X on something 20 times because there's 20 markers in the same spot. So that's one thing to be careful of. And then of course, all these markers in the actual client side, on the JavaScript side, they're tracked using these arrays. So as you can see over here, in the corner, this is actual snippet from the JavaScript code where basically you have this list of markers, member markers, and the intersection markers. And so again, those correspond to the JSON that we're returning and all of these objects on the map that we're going to be interacting with. And what that allows us to do is you can see on these markers, there's a little pop-up. And on the pop-up, there is, you know, a trash icon, a members icon, and an X, right? These buttons right here aren't built in. These are something I added myself because one thing is some of these things don't come with the capability to remove a marker out of the box. That's one of the things I ran into with Leaflet is you can't remove markers. It'll make markers, it'll close them, it'll put that X there for you, all that, but it won't remove them. And so you have to come up and create your own little way of deleting these markers. And so with this trash icon and with this array, it's real easy. I basically link up the ID of this guy, this marker. And when this is clicked, I just pull up that ID, pull up that marker, and then boom, I can remove it. And if I need to remove, again, the other piece of this is these buffers are tied to the actual marker. And so if I want to remove the marker and the buffer with this trash icon, again, I can just use that ID of the marker, pull up that marker, remove it, remove its buffer, and boom, yeah, I've got that deleted off the map. Similarly with the find members, I can hit that and I can find members around a certain buffer as opposed to finding them around all the buffers. And so of course, a lot of these have their own little bulk action flavor. And so you can see that's kind of up here in the right corner. This is basically find me all members between all my buffers. This is of course, you know, delete everything. This is show hide, you know, my members. And then of course, if I click a member, this is kind of what pops up here. If I click one of these circles, and you can see there's a little hyperlink here. And this is what I was kind of alluding to earlier is with the return of the member results, I'm able to pass that member ID back. And then I can easily build up a little hyperlink, you know, that they can go to see the view page for that member. And so that kind of is a little bit of extra functionality they didn't necessarily ask for, but at the same time, I have all these members pulled up. You know, I already did the database trip. And so I can easily just return, hey, here's the IDs for these markers, and boom, I've given them a little extra functionality with no extra real cost. And then the last thing you see over here is this ruler. This ruler is, of course, the radius control. And so when you hover over that, it turns into a little slider, and you can slide it up and down and control the radius for everything. It uses some simple jQuery templates to actually generate these. So the way that they're displayed, the members in radius, hyperlink, these tool icons, all of that are controlled by these small little, again, just simple templates, right? They're just script templates. And then I'm just using jQuery to replace certain items in them. And so that's about it. Oh, the other piece here, yeah, is so there's some other little gotchas that are into. So one is the member coordinate points. If you use them as just markers, Leaflet actually tracks all markers as DOM elements. And so if we get back, you know, thousands of these, and you make thousands of DOM elements, you'll notice your page starts to kind of lag a bit. But the upshot is, well, you can always just do a circle marker. And a circle marker is essentially just a drawn on circle. And it doesn't create a DOM element or anything like that. And so if I go back, like you'll look at this and you see these dots and they all almost look the same, but in reality, some of them are actual markers, some of them are just circle markers. So that's one gotcha I ran into right away. Notice the map kind of started choking when I started loading on member points. And then the other thing is the radius slider. That actually, I looked into wiring up one myself because I was thinking, hey, this can't be that hard. This can't be, and that turns out there's a little bit more to that. But again, luckily, as soon as I decided, well, let me see if Leaflet has something for this. And then boom, Leaflet, there's already an open source plugin for a Leaflet slider. It's real simple, real small, and adds the slider real nice. So toss that in there. So those are just some technicalities or gotchas I kind of ran into in the end. So that's about it for the map. And like I say, I'll jump into a coding overview / demo here in 1 second. But the other piece I wanted to cover with this is the actual geocoding of these addresses. So that was another ticket that I had that kind of related to this. And it was basically, hey, we're going to be, you know, inputting in members' addresses like a member, you know, or a subscriber or dependent. And we would like to have those geocoded just automatically, right? We want a member coordinate entry for that address. And so again, with this, this is why we have these considerations up front, is because I could say, well, hey, good news. OpenCage has a really nice .NET Standard SDK, so we can easily, you know, port that in. We can create a nice little wrapper for it, a wrapper service to wrap that SDK's call, and just inject it in there. And basically, we can put our application-specific logic in there. So this might include like formatting the address. So for OpenCage geocoding, when you do reverse geocoding, they want the address, you pass them in a specific format. Mainly, they just want address line 1, comma, the zip code, comma, the city, comma, the state, just basic comma separated address, very simply. They don't want, a number of things. And so they have a nice list of their best practices that they recommend. Hey, if you're going to ping our API endpoint with an address, this is what you should kind of look at. And it's really nicely laid out, has things like basically, hey, limit your result set if you're only looking for 1, 2, or 3, results, and you're only going to take the top one, or, make sure you don't pass us address line 2. They don't need like unit B or apartment 108. That's just going to throw it off. So you can kind of include the formatting of this address before you pass it to this geocoder. You can also handle validating that the address they gave you is actually correct or actually seems accurate. And so what they do provide you, and a number of these geocoders will, is a confidence level. And as they'll point out very quickly, confidence isn't the same as, oh, we think we've got it right. It actually corresponds to a bounding box size. It corresponds to what kind of bounding box they can draw around the address they're giving you. And so basically, if they're able to draw a very small box around the address they're returning you, the confidence level will be very high. They think they've nailed it. And so you can use that in combination with another couple pieces, like maybe the city, maybe the zip code. Like those shouldn't really differ, right? So you can check, hey, the address I got back, is that right? Or the coordinates, because they also return the address for those coordinates that they've returned to you. And then, of course, if there's any errors communicating with their geocoding service or their API, or any formatting errors, you can go ahead and handle the logging of those in this wrapper service as well. And then with this wrapper service, I can just easily inject that into whatever places I need it. And then on top of that, I have an interface for it. And so for the testing, it's extremely easy to mock that out, right? Because I don't want to have to be pinging OpenCage's API for my tests. I'd rather just say, hey, OpenCage is going to return me this, you know, and this is what I'm expecting back. And then you can write your tests around that much more easily. And so that's the forward geocoding part of this. So with all that, I'll do a quick pause for questions or comments. Nothing? All right.
Hey, Johnny, I got a question. So
Oh, yeah,
you mentioned that sometimes you render those points as drawings versus adding something to the DOM. How did you determine what you were using? You said some of the times you rendered it one way versus the other.
Right. So it was mainly, I was rendering everything originally as markers. And I didn't know that they were literally making a DOM element for each marker. And so when I thought of, oh, well, hey, I'm going to add the member coordinates to the map too, because again, that wasn't an explicit requirement. That was something that I just knew, well, hey, I've got the data set, I've got these IDs already. I could do that really easily because I've got that data. I just got to return it out. As soon as I wired that up, the map got really slow. And then that's when I started looking it up, and they were like, yeah, if you add all these markers, it's going to make all these DOM elements. And so basically, if you're going to load thousands, like I'd say 200 plus really, of a large data set that's being returned to the map, then you're going to want to render that as just a overlay, basically. And Leaflet, it's a circle marker is what they call it, but basically it doesn't have the overhead of this DOM element or the marker. It doesn't track as much about it. It just draws it on the map. And then you can also wire click events to it too, of course. But so that's how I determined to go ahead and use the circle marker versus just the markers themselves.
Got it. Thank you.
No problem. Anything else?
Johnny, I got a question.
Yeah, what's up?
Is there a reason you went with jQuery versus like another JavaScript library? Were they already using jQuery for most of their project?
Well, so this actually is not. Okay, let me think how to put this. So Leaflet and OpenCage aren't jQuery specific necessarily. As far as I saw, that Leaflet seemed to be a little more framework agnostic. Same with OpenCage.
Yeah.
Now, as far as DBT goes, yes, DBT is using jQuery. So it was like, yes, of course, I'm gonna just go ahead and use jQuery.
Right.
But you don't have to.
Gotcha. Okay.
Anything else? All right.
Hey, Johnny. Oh, sorry.
No.
Yeah. So, this is Eduardo, by the way. So, when you were mentioning about the paid, there were three options you chose for the title providers. I think the second one was the OpenStreetMap, right?
Yes.
Okay. And I mean, just something. Yeah, that one. No.
Yes. Sorry.
That one. So you said that on OpenStreetMap you will rely on their API.
Yes.
So for Mapbox, I mean, wouldn't it be a similar scenario where they have their own API?
Yes.
And if it's, I mean, it's just the SLA that they have a better SLA because it's a paid subscription.
Exactly. You're
Okay.
exactly right. Right. Basically, you're ultimately going to have to rely on some API unless, again, you custom or download your map tiles and then, source them.
Right. Yeah, I was wondering that. Yeah.
Right. And so, like Mapbox, though, again, when you pay them, they have a number of, like you say, these SLA requirements. So they're like, hey, our API is up all the time, and hey, we're going to get you these responses in this amount of time and all that. With OpenStreet, when you go for free, it's like, here's what you got. That's all you can get.
Yeah, if it's down, it's down, and nobody really cares, basically. Yeah, no, I was just wondering if it was the case that there was a cloud API, or you had to like deploy it to your own on-prem services or service.
No, right. And you're right.
Okay.
It is cloud, and I mean, I'm willing to bet some of these have an option where you could host it yourself. But you're right, these are all cloud based.
Okay. No, thanks.
No problem. All right, so we'll go ahead and jump into a quick demo. So let me refresh. I might have timed out. But this is the DBT DEMA application. I went ahead and took the liberty of scrubbing all the data, of course. So there's no Social Security. There's basically no PII in here. It's just random addresses. So basically, this is the map, right? So I can come to carrier population, and I can click different points on the map and say, oh, maybe I want to, see all the members within these areas. Maybe at first I just want to see the members over in this circle. And so you can kind of see that bounding box algorithm I pointed out earlier, how it's looking for the northmost and the southmost and the eastmost. And what that also gives you the benefit of is now the user can actually see, oh, well, hey, if I adjusted this point maybe just a little bit over here, I could include this many more members. So it kind of gives you two benefits. One is it makes your algorithm more efficient, but then two is you have the added capability of showing them that. So as I was pointing out, these buttons work, accordingly to this marker. So I hit, find members on this guy, maybe find members on that guy. Or of course I can say, find me all the members and intersections on all of them, right? And of course, when I do that, it's going to actually show me the, the intersections counts, right? And so again, these you can kind of hide and, redisplay if you needed it. If I didn't want to see this one right now, and I did. And then of course I can remove these, so I can completely delete that buffer. And then as I pointed out, these member markers each have their own little hyperlink, and then they display, the address. So I could navigate to any of these subscribers or dependents if I needed to go, oh, let me check that one real quick. And then there's also, of course, a bulk action to go ahead and remove all. And then there's a show and hide all members. So let's say I didn't really care about the members and where they were. I just want to see counts. I can show that or go ahead and hide them. Or again, like I say, I can blow all this away, say, oh, it's done. So maybe, again, as I was mentioning this slider over here, I could say maybe actually I need a radius over here of around 3. I need, radius of over here around 9, something massive. And then maybe again, a little 5 for over here. And as I pointed out, the OpenCage plugin for Leaflet's really nifty in that it gives you this little search box. And what you can do is you can kind of type in an address, hit search. It went ahead and made a geocoding request, shows me the results right here. And then again, I can just select that from that results, and boom, it's going to pop me a marker there. And again, I can do all the same functionality that I would need to from anywhere else. So it gives the user the flexibility of entering an address or just picking a mark on the map. And then as you can see, they can customize their radius. And that's about it for the UI side. If we kind of dive into the code side of this real quick, I can point out some of the things I had kind of alluded to earlier. So let me do extensions. So as I pointed out, a lot of these things I went ahead and put into an extension class because a lot of them are based off of a geocoordinate, or like I say, I made this I-coordinate class or DB geography. And so with that, I can kind of just use these wherever I want as I need them. And this is that method that I had mentioned earlier, has a little bit of trigonometry in there, but it very accurately counts or calculates, another latitude, longitude, north, east, southwest of a certain point, right? And so that, of course, is used in my service over here. So I got this member locator service, not the biggest service, doesn't need to be, pretty simple. It's just about over 100 lines. And again, as I kind of went over, it's of course going to go ahead and pull up all the member coordinates according to a bounding box that it sets up. So it's going to set up this bounding box down here. And this is where we can see it calculating derived positions. So for north, south, east, west, right? And then we're going to go ahead and go through these member coordinates that we pulled up from the database and go through the buffers that have been defined around them. Say, hey, is this member in the buffer, And after we've done that, we're going to go ahead and start trying to find intersections and intersection counts. And so this intersections is what I was mentioning earlier. This is a recursive function right here. And so you can see it's looping through basically all the areas and then all the other areas. So it's got to go say, hey, for this area, does this area intersect with any of the other ones I was past? And as it does that, it finds an intersection, checks if it exists. If it does, it's going to go ahead and add them and count the members. And then at the end, it's going to say, hey, did I find any intersections? Because if you did, then we have to go check again. Did any of the intersections we found intersect? And so that's where we could see the recursion call right here, find intersections on any of the intersections we found. And then at the end, we're just going to return all of them that we found as intersection results. And then this is the actual view page over here. You can see there's not much to it. There's mainly the templates for the pop-ups. Some JavaScript includes, and the map initialization. And what I've done is I put a bunch of the map-specific JavaScript into its own little JavaScript file over here, so it could potentially be reused later. But admittedly, it's pretty specific to, of course, this feature. And so you can see it tracking a couple click events and whatnot. And as I pointed out, it's tracking all the markers that you see on the map and everything you see displayed as these little JavaScript arrays. And that's about it. So let me pull this back up. Whoops. Questions or comments on that or anything?
Johnny, Javier here.
Hey, how's it going?
Hey, so, did you mention that you required data entity system data.entity to do some operations?
Yes, yes. So specifically.
So do you have a sample of how you're doing queries against the, I'm assuming that you have all of the information in the SQL Server database. So maybe you have some examples on how to do those queries.
So they are using, pull this back up. So at DBT, they're using Entity Framework. And so for the actual find member coordinates, all we're going to do is they have a repository pattern, but essentially that is just wrapping a DBT context or DB context. And so we're just going to do a query over the member coordinates, and all we're doing is we're restricting it to the latitudes that we've boxed off. So the highest latitude, lowest longitude, lowest or and whatnot. So basically north, south, east, west, those boxes, we're going to look up only coordinates within there. And so as far as the actual usages of these classes, a lot of it lies inside these extension methods. So up here at the top, you'll see it including system.data.entity.spatial. And so if I pull that out, you'll see all of a sudden DB geography goes away and DB geometry. And we use that to make well-formed text, or sorry, we use well-formed text for the latitude, longitude to make a DB geography. And then similarly, you can do the same with a DB geometry. And the reason we need some of this is, as I pointed out, one is to get the centroid. Another is if we come back over here where we're calling intersection, you can see that's a DB geography call. And so that's kind of how these things are being calculated. The database is literally, though, only hit once per call or per request. And it pulls up all the member coordinates you're going to be dealing with in that request. So if I come back out to this guy. So when we look at this page, when it does a search, let me see, I don't think I stopped it. I don't think I timed out either. Let's see. So when it does that search, it is only looking, it's only going to pull up one set of member coordinates, and that's going to be the bounded box of coordinates that fall within this area. And then it's performing everything else on those coordinates just in memory.
I see. Okay.
Did that answer your question, or was that?
Yes.
Okay, perfect. Any other questions or comments, concerns?
No, not from my side. Really good presentation, Johnny. Thank you very much.
Perfect. Well, thanks a bunch to y'all. Thanks for giving me the time of day, and I hope this was informative and helpful. If any of y'all have to deal with any of these maps or anything like that in the future.
Beautiful,
Oh,
Johnny.
yeah.
Thanks.
Thank you, Johnny, for this session, and thank you all for joining. Just remember, we're going to have another, sorry, next Wednesday, we're going to have another virtual session. It's going to be by Ricardo, and he's going to talk about Kubernetes and Octopus. And well, I'm going to send you the invite today. And